somewhere in this area, we finished. Okay, so we skipped this one because we looked at, the last thing we did was R on the calculator, okay? This is the formula for R, but like I said, I will never ask you to use it. You will never have to use it, but you can do it by hand. It's actually not that bad. There's a lot of multiplication and adding, that's all it is. But you will never have to do that because the calculator will, luckily our calculators will calculate R for us. You will never be asked to calculate by hand, but you do need to know how, should be how to find. Okay. Okay, so that was the last thing we did. All right, so remember, correlation coefficient is the same as R. So sometimes it's called correlation coefficient because it's a number assigned to R. Remember the numbers for R, scroll up a little bit right here. They go from -1 to +1 based on their strength, based on their direction, okay? So that's what I'm talking about when I say correlation coefficient. Okay, so correlation, a couple facts about correlation. So these right here are multiple choice type questions waiting to happen. A lot of information. Anytime I give you information about something, most likely you're going to see this in a multiple choice question. They're going to ask you some questions and they're going to say, which one of these is false? Or which one of these 5 things is true? Okay, so that's where these come in. All right, so R. So correlation coefficient. Correlation measures the strength of the linear association between 2 quantitative variables. Linear association, right? Form is only linear, we're only doing linear, right? Earlier, one of the first things we did, or was it here? Strength, form, direction. Well, form's always gonna be linear. So linear relationship, linear association, linear correlation, remember? And then direction's either gonna be positive or negative, okay? And then how strong are those dots to align? Very strong, almost a line or a straight line. Moderate, kind of strong. Weak, not really. Okay. Okay. Go back to where we were. They measure the linear association between 2 quantitative variables, 2 things that we can quantitate in numbers. Okay. So for example, this one here, years since 1990. So years we can quantitate, and versus the world record marathon time, right? As years have gone on, the world record for the marathon, 26.2 miles, has gone down. People have gotten faster. Technology has gotten better, so people can train better, right? Better shoes, you know? In 1990 and 1910, the type of shoes they wore compared to the type of shoes marathon runners run now are totally different, okay? So, and then conditioning and stuff like that, reasons why time's gotten faster. This one here, years since 1990, again, so years, that's the quantitative variable, that's one of them. The next one is 100-meter record time, sprints, same reason they're going down, okay, as marathons, okay? Okay, so that's what it means by between 2 quantitative variables. Excuse me. Next one, correlation makes no distinction between explanatory and response variable. Okay, so correlation makes no distinction between explanatory and response variable. What does that mean? That means on this graph, which one's X? Years, right? Which one's Y? Time, right? Yeah, time. So in terms of R, if I were to switch these and make this the Y and make this the X, flip-flop them, R would stay exactly the same. That's what that's saying. We never do that, but there is that relationship, okay? So if I were to take years, 0, 20, 40, 60, 80, 100, 120, and put it for the Ys, and then take the hours, 2.0, 2.2, 2.4, 2.6, 2.8, 3.0, and move them down to x's, R would stay exactly the same. Okay, R would stay exactly the same. And I'll show you that on the calculator very quickly. We never do that. Why would we switch X and Y? We don't. But they're just saying that it's not affecting R. It'll affect other things, but not correlation. Okay. Let's see. R does not change when we change the units of measure for X, Y, or both. So for example here, instead of hours, you see this guy has hours, right? So 2 hours, 2.2 hours, 2.4, 2.6, 2.8, 3 hours. Let's say I change these to minutes. So I multiplied all of my 60, right? To change it to minutes. So instead of 2 hours, it's 120. Instead of 3 hours, it's 180. And then these guys in between. That wouldn't affect R either. Okay? Because I'm not changing anything. I'm just changing the way it looks, right? It's like changing a $5 bill for 5 ones. It changes the way it looks, but it's not changing the value, right? So that doesn't affect it. Let's see. R has no unit of measurement. So if like you get something that has R equals, let's see, one of these guys up here. This guy, right? Either one of these guys. R is just a number to be used on this number line here. It doesn't have a unit of measure. It's not like feet or inches or hours or minutes. It doesn't have a unit of measure. That's one of the only things we don't have to label because it doesn't have a unit of measure. Okay. And then the last one, it's very sensitive to outliers. Very sensitive to outliers. And we're going to talk about that one a little later. Okay. So for example, if I was to put an outlier, so outlier means doesn't fit the pattern, right? So the pattern here is as years goes up, what's happening to the hours? Okay, so something that wouldn't fit that pattern is something like this up here, right? This is about 2000, a little after 2000, and slow time, right? Doesn't fit the pattern. That's an outlier, okay? So if I were to include that dot there, that would greatly change R. It wouldn't be negative moderate. It probably would still be negative, but it might be more weak now because you got to contend with that dot. That dot's so far out of there that it's not moderate anymore so much, right? So that's what I mean. It greatly affects what happens there, okay? Okay, so let's do a problem where you're going to do 4 steps, okay? So if you need a calculator, go grab a calculator. If you already have your calculator, we have 2 lists that we're comparing to each other, 2 quantitative variables. The first one is miles driven. How much have you driven the car? The second one is price. How much is that price? How much is it worth, or how much would you sell it for? Advertised price, sorry. Advertised price for Honda CR-Vs from 2002 to 2006. Okay, so put those in L1 and L2. Okay, so once you are able to put all these numbers in there, then you can answer number 1, number 2, number 3, or A, number 1, number 2, number 3, number 4. So remember how to do the scatter plot on the calculator, and then how to write it on, how to put it on paper from the calculator. Okay, so explanatory response, if you're still working, go for it, but I'm going to start. Explanatory response. So explanatory, going back to the very first slide that we had stuff on besides the title. Response variable is an outcome. That's why. What happens? Explanatory variable may explain or influence change in a response. Okay, so we had to figure out which one is a response and which one is explanatory. So which one? We have two options. We have miles driven and we have price. So which one of those is going to be the explanatory? Miles driven. Yeah. Now, I caution you because there are some times, it doesn't happen a lot, but once in a while, they will pull one of these. They will say, oh, this is the Y and this is the X. Okay. Doesn't affect R. Yeah, it doesn't affect R, but it will affect other things. The graph and the association, right? It won't affect the number we get for R, correct? But it will affect some other things that they're asking us. So if they only ask us for R, you're right, doesn't matter. Absolutely, doesn't matter. But they're asking us for a couple other things, so be careful with those, okay? So when you read these, try to figure out what are they trying to do? Well, they're trying to figure out, does miles, how many miles you've driven these cars, does it affect the price? That's what they're trying to figure out. So this is, for that reason, this is going to be X and this is going to be Y. Okay. So miles driven is the explanatory. The response is price in dollars. Okay. Use your calculator, draw scatter plots. All right. Well, here's a scatter plot here, or here's the setup for a scatter plot. So when we do that, remember, any graph we want is in stat plot. So we're going to go to the first plot since we only want one graph. The one we want is the dots. The dots. L1 is my response, or my explanatory X, and L2 is my response. Okay, so everything's ready to go. I'm going to go the zoom stat. There you go. So what I need to see are those dots. Okay, so I'm going to try to make the best I can a picture. Oops. Bring it back here. Okay. But if you give me that, you won't get full credit. Why not? What am I forgetting? The labels, yeah. The labels in terms of what's X and what's Y. Well, we just said miles driven is X. And we said that price in dollars is Y. Now, I don't need tick marks for that, but if you want to, I'm not taking points off. Like if you want to say, you know, start to label them like this and actually label, I'm not going to take off points for that, but you don't need to do that. When you use the calculator, you don't need to actually put individual ticks. You want to, go for it. Okay, that's all I need to see. Gives me a picture. I can see what's going on, which is the next question. The next question is describe the association. Describe the association. So what's happening here? What's happening in this picture? That's pretty much what they want to know. What's happening in this picture? What's happening in this picture? Say it louder. It's definitely negative, right? The dots are going down as miles driven gets bigger. So as miles driven increases. What? No, I'm just writing down what's happening. As miles driven increases, price of the vehicles is decreasing. Yeah, that's the story, right? That's what's going down.
I just wrote negative strong linear because do we have to write it in a sentence?
This is not the answer to the question. This is just what's going on. Yeah. So when I said what's going on, that's what I meant. Now I'm going to go back and answer the question. Yeah. Yeah. So no, I'm doing 3 now. I'm just explaining what the heck's going on. As miles driven increases, the price of the car is going down. Okay. So now let's go answer the question, right? We need 3 things. We need strength, direction, and linear association. Since they used association, let's use association as well. Okay. So we're going to say there is a now, is it strong, moderate? We said negative, right? So we could say negative, comma. Is it strong or moderate? How do we know? There you go, right? That's going to tell us strong, or that's going to tell us, right? Which we're going to do in number 4. So let's skip this for right now because there you go, right? This will tell us whether it's strong, moderate, or weak. We know it's negative. I can use my eyes to figure out if it's negative. But in terms of moderate or weak or strong, let's use R, okay? So we're gonna leave that one blank for right now. I'm gonna put linear relationship. Okay, so let's go calculate R. All righty. So to calculate R, you go to Stat, Calc, number 8, yes. So linreg, there's 2 linregs. You want the linreg that's on the bottom. You want A plus BX. That's the boy we want right there, A plus BX. So number 8, or scroll down there. L1, L2, yes, yes, yes. Yes, 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 yes. Calculate. There's my R down there. Okay. So usually with R, again, we go 3 spaces. The only thing we really go 2 spaces for is z-scores. It's a negative, yeah. Because it's negative, right?
Oh, right.
It's, there you go, yeah. We said negative earlier, so hopefully it's a Monday.
Exactly. See, he knows. He gets it. Look, what was I supposed to do? Homework?
Okay.
Exactly.
So now, this guy right here, this is going to tell us whether it's strong, moderate, or weak. It's negative. We knew that. Our eyes told us that the dots were going down. So this fits into the strong category. What am I talking about? I'm talking about right the number line. Yes. And you can't see it because this is covering it. This number line right here. The one we drew, it's the same as this number line, but it's just more visual. So negative 0.874, whatever it was, is in this area here, which is strong negative. Okay. So we're going to go back to here. And we're going to put, there's a negative strong. I guess grammatically, it probably sounds better to put strong before negative, but I don't care. You could put strong negative, you could put negative strong, I don't care. I'm just looking for keywords. I'm looking for positive, negative, strong, weak, moderate, linear relationship. That's what I'm looking for. Okay, so find and interpret R. How do we do that? Keep going. We already found R, so we found it. So how do we interpret that number? How do we interpret R? You explain exactly what that number is. So how do we explain what it means? Very see below. Well, let's go look to see where any slides we went over that have R in them. Okay, so we'll start here. Nope, explanatory response, no R. Scatter plot, no R. No. Oh, we have a correlation here. Isn't R a correlation? Well, let's skip that. Ooh, there's correlation. Right, it's the definition of R. And then we go here. So how do we interpret it?
Wouldn't this be a strong linear?
That's all it is. Once again. That's what it is. Interpreting R is form, linear, strength, strong, negative linear relationship. So it's just the same thing we had. Yep. Yeah. There is a strong negative linear relationship. So honestly, it's just looking at the number line and figuring out where does it fall. The number line will give you strong negative, strong positive, moderate positive, weak negative, and you just have to add linear relationship. So the reason I put that one there is because it's different ways of saying the same thing, right? Interpreting R is describing the association, describing the correlation. It's the same thing. Okay. All right, so let's jump to the one I gave you for today. That should be the rest. I believe that's the rest of chapter 3 is on those notes. So we're going to jump to the next, once I get these guys. Sorry, trying to airdrop. Let's see, here we go. Okay, here we go. Yep. What's wrong with it? Oh, okay, yeah. So, oops. So if you got a calculator that doesn't have R, it was in the, you gonna show her? It was in the video from Friday. And I'll show you again, so it's gonna be in this video. Yeah, you gotta add it to the catalog. So the catalog is down at 0. You only gotta do this once. Once you do it to your calculator or to the calculator you're using, if you always use that calculator, then you don't gotta do it anymore. Okay, because mine was already done because I did it last year. And then you're gonna go all the way down towards diagnostics on. These are all the functions of the calculator. So everything the calculator does is listed in this catalog, but we don't want all of those things. We want diagnostics. All of those things, yeah. Would you like to calculate R by hand?
No.
There you go. I think that's the price, worth the price right there. All right. Okay, yep, so now it's on. Now you don't have to change it anymore unless you use another calculator that hasn't been turned on. Okay. All right, so if you're not sure how to do that, just watch either Friday's video or the video from today, and it'll show you. Okay, so the next big idea is this thing called linear regression. Remember linreg on the, it says linreg twice. That's what linear regression is. Linear regression is linreg. So what is it? Well, it's got a couple names. One of the other names is called line of best fit. It's another name for it. Okay. or just simply a regression line. Sometimes they call it linear regression. Sometimes they call it regression line. Sometimes they call it line of best fit. Sometimes it's called the least squares regression line. It's got a bunch of names, but it's all the same thing. So what is it? It's a line that describes how a response variable, y, should probably put those in parentheses, changes as the explanatory variable changes as well. So we often use a regression line to predict. That's the main thing right here. We use it as a predictor of what's going to happen. Predict the y value for a given x value, sometimes called the line of best fit. Okay, that's the definition. So before we go on to the next one, equation of a line. When you hear equation of a line, what do you think? There you go. Y equals mx plus b, right? It's stuck in your head back from probably 6th, 7th, 8th grade, and you're just always there. You just y equals mx plus b, y equals mx plus b, right? Well, that's what we're going to use, except in statistics, they don't use m, they use a and b, okay? So this is y equals mx plus b right here. It's just they use different letters, right? So back when you did y equals mx plus b, what was m? Slope, right? Guess what b is? Slope. Don't ask me why they use b for slope instead of m. I don't know. Okay. The next thing, what was b? Y equals mx plus b. What was, so m was slope. You guys know this, I'll be impressed. So this one's slope. What was b? There, oh, you guys are good. Y-intercept, right? So guess what a is over here? Y-intercept. Okay, so it's nothing you guys haven't done before. It's just got different names, different letters attached to it. I wish they would have just stuck with y equals mx plus b, but they didn't do that. So, okay. You can change it, but it's just everywhere else you see it, it's going to be a and b. So you can change it on your notes, but then it won't match your book. It won't match the calculator. So, okay, so a and b, a is the y-intercept, b is the slope, okay? Y hat. So instead of y, it's called y hat because it's got like a little hat on it, a little, I don't even know, it's like a little, what do you call it, caret? The button that's right above the 6 on your computer keyboard. Okay, so that's the predicted value. So the predicted value is y hat of the response variable for a given x. So if I plug in x, whatever it gives me for y hat is the predicted. Okay. Okay, so here's the thing. Sometimes they use other symbols besides y equals mx plus b and y equals a plus bx. Sometimes they use b sub 0 and b sub 1. I have no idea why they do this sometimes, but I wanted to throw it on there just in case if you saw b sub 1 and you're like, what the heck is b sub 1 and b sub 0? B sub 1 is slope. B sub 0 is y-intercept. I believe our textbook doesn't use that one. I believe our textbook uses A and B, but sometimes they will use it. Okay, so that's why I want it's the same thing, just different symbols. Okay. All right, so least squares regression line, right? So we have this scatter plot already. We just drew it in our notes about 5-10 minutes ago, right? So let's look at it again. So look at your calculators and let's see what's going on for this data here. Oops. Zoom, stat, let's get the picture back. We said it's strong negative, right? Strong negative linear relationship, okay? So what we're gonna do now is we're gonna come up with a line, one line that best represents all of the data points. Best represents all of the data points. Now, is there one line that could go through and touch every single blue dot? Not a straight one, right? It would be many lines. We only have one, right? So what would that line look like that best encompasses all of the blue dots? So let's see. Here we go. Would that be the best one? No. Would that be the best one? Would that be the best one? So what do you want me to do? Tilt it, tilt it. Okay. Something like that, right? Something like that would be the best fit line. You guys are right. Okay. You guys are correct. Now our calculator will do it for us. All right. This is the only time we're going to use the y equals. We never use y equals in this class except for what we're going to do right now. Anytime we want to graph a line. Okay, so what we're going to do now is we're going to figure out what is the slope and y-intercept of that line that fits everything. Okay, so let's go back here. Okay, so the same buttons, the same commands that we did for R, we're also going to do for A and B. Because if you notice, A and B were there. We just didn't look at them. Okay, so the same commands. So stat, calc, right? We don't want AX plus B because that's not how it's written in our notes. We want A plus BX. That's the one we want. Number 8. L1 is my X, L2 is my Y. Frequency list, don't worry about. See this one where it says store regression EQ? That's the linear regression equation. So we want it to remember. So you just hit enter, calculate. It'll give us R again, right? But then if you look up, there's also A and B. We didn't look at it the first time, but it was there. So what we're going to do now is we're going to write those down. You notice how it says A equals, B equals. We're going to write those numbers down. That's the slope and the y-intercept for the least squares regression line. So A is a pretty big number. 18,773.284. Yeah, I'm not gonna write the whole thing. 3 spaces and you're good. Slope is a negative small number. Slope, negative 0.086. Okay. So put those together, right? Because it's y equals A plus BX. Let me write this down. Y equals A plus BX, where A is y-intercept, B is slope. Okay. So let's put them together in one line. So, oops, not y, it's y hat. Okay. That's what we're going to do up here. We're going to put the equation here. So y hat equals A. A was 18,773.284 plus BX, which is negative 0.086 x. There's our equation. Okay. Here's the thing. They don't ever want you, statisticians in a math class, math 1, math 2, math 3, that's perfect. Done. Move on to the next one. But statisticians don't like they like it to be in context. What are we doing? So they don't like X and Y. What they want are, what are X and Y? So let's start with X. What is X? Didn't we say earlier it was miles driven? So instead of X, we're going to put times, and we're going to put in parentheses, or just put in parentheses. You don't have to put a dot. Miles driven. There you go. What would Y hat be? Yes, good. It's not price, it's estimated or predicted price, right? Because we saw this earlier. Y hat represents the predicted value of Y. So we're not going to say price, we're going to say predicted price or estimated price. That's in context. Okay, so that's what they want in context. Okay, so in context means use what they're giving you. Don't use X and Y. What is X? I don't know. Well, it's miles driven. Okay, it's in context. Okay, so now, how do you, one of the big things they always have you do is interpret slope. What does slope mean? Slope is rise over run, right? Isn't it rise over run? Well, why do we say slope is rise over run? What leads us to say that? Rise. So what does rise mean? Up or down. So when I'm talking about up or down on a graph, what does that mean? The Y value, right? So we say change in Y. The little triangle means change. Change in Y over change in X. Okay, exactly. We don't want X. That's why I gave you the sentence frame. Okay, so that means, so this is a little sentence frame to use when you're interpreting slope. For every 1 mile driven, what's the response variable? Price. Is it going to increase or decrease? How do we know it's going to decrease? You're right. Because it's negative. Good. Decreases by that number there. Okay, so let's write this out. For every 1 mile driven, price decreases by dollars. Because it's decreased. Okay, so why did I put the negative? It's a negative number. So why didn't I put negative here? Well, you can lose money, right? But why didn't I put negative here though? Because you're already saying it's going down, right? It decreases by, sometimes people will do this, watch. Sometimes people will do this and it's wrong if they do this. If you're decreasing by a negative, what does that really mean? You're actually increasing, right? It's a double negative. So if you're going to use the word decreases, change it to positive. If you're going to use the word increases, you can leave it as a negative. Increases by a negative or decreases by a positive. Okay. So that says For every 1 mile you drive this car, you're going to lose about 9 cents. That's true with all cars. All cars. Very few cars. There are a few cars. Actually, right now is a bad time because car prices are going up because of supply chain issues. So, but normally, every mile you drive a car, you're losing money. That's why people say cars are the worst. Cars are not investments. They get you from point A to point B. Because if you buy a nice car, great, but you're not going to get the same amount of money you would unless it's a special type of car. If it's a special type of car that people want and they don't make a lot of them, then hey, it retains value. Like classic cars, right? Classic cars from the 50s and 60s and 70s. There are some of those cars that actually increase in value. Why do they increase in value? They're rare. They don't make them no more, right? And if you take good care of yours, there's not a lot. So you can sell for whatever price you want, right? But if I go buy a 2021 Toyota or Honda, good cars, great cars, but why am I going to pay top dollar for that used car when I could just go buy a new car for the same amount of money, right? Like if I drive a car for 6 months, great condition, has barely any miles on it, and I try to sell it at the same price that I bought it for, people are, you're crazy. Why am I going to buy your used car when I could go to the dealership and buy the same price for a brand new car, right? That's why cars are bad investments. They're not investments, okay? Because they lose value, okay? And that's what it's saying here. For every 1 mile you drove, oh, you lost 9 cents. You lost another 9 cents. You lost another 9 cents. You lost another 9 cents, right? That's true with cars, unless it's one of those special rare cars, okay? Even nice cars. What's the nicest car possible? Like a Rolls Royce. Those lose value too, because guess what? Right now they're making more. So if I want one, if I have enough money to go buy one, I can go buy a brand new one. Why am I going to pay the same price you paid, right? Now there's some cars, they only make like 10 a year because they're so custom made, right? Those keep value because if they only make 10 a year, you're going to need cars. And like right now, car values are going up. Why are car values going up right now? Yeah, microchips. Every new car has a computer system in it, and there's not enough microchips. Okay. There's not enough microchips to put in the cars. So you go to a car dealership and the cars that they do have, the prices are going to be higher because demand is high and supply is low. So yeah, so right now, but that's rare. That's just because of the pandemic. Factories shut down. So now they're picking back up, but they can't meet demand. Okay. Okay, so last one. When explanatory, so how do I interpret this number here? 18,773.284. There we go. When miles driven, when Y is 0, response variable. What's the response? Price is that number right there. So tell me what this means in plain English.
A brand new car is gonna cost you.
Yes, that's what it is. Brand new car. No miles driven. Thing hasn't been driven at all. It's so new it hasn't been driven even 1 mile. That's what the price is going to be. So it's a price, so we want to put dollars on it. That's what y-intercepts are. Y-intercepts when x is 0. When x is 0, what is y? That's what a y-intercept tells you. Okay, but the big thing in this class is interpreting those. So that's why I put this sentence frame on there. So for your assignment that I'm going to post today, there's going to be some of those because I want you to get used to interpreting them so that it becomes second nature. It's not hard. you have the sentence frame here, so it's not hard. You just got to get used to doing it. Okay. All right. Okay. We will pick up tomorrow. Well, our homework assignment's not going to be due till Wednesday.
Classes that need to be homework.